Alright guys, today we're going to look at one of the last new things we're going to have about derivatives, and this is something called the product rule. But before we learn the product rule, we're going to learn two new derivatives, and that's going to be the derivative of sine of x and the derivative of cosine of x. So we looked at these graphs a while ago, where if you look at the slope of the tangent line at different places, if you took the graph of sine of x, which looks like that, if you were to graph the slopes of that tangent line, you'd get 0 in a few places, some positives, some negatives. What that graph would look like that shows those tangent line slopes would actually be your cosine graph. And then just very similar to that, if I were to take the cosine graph, and this isn't very accurate, just kind of the basic shape there, then that would actually be the graph, not of sine, okay, but it would be the graph of the tangent line slopes would be negative sine. So those are just two derivatives that we're going to need to know. Now, the product rule comes into play when I'm trying to take the derivative when I have two functions multiplied together. And what the product rule is the derivative of f of x times g of x is f of x times the derivative of g of x plus the derivative of f of x times g of x. So basically, the order here doesn't matter. If you were to flip these two, that would be okay, because we're adding. What really matters, though, is that you're matching up one function's derivative with the other function's original. So I have an original function matched up with the other derivative, and I have one derivative matched up with the other function's original. So just mix and match the two derivatives and originals. So to look at a couple examples here, let's look at this equation here. So if you wanted to just use the power rule, you could, but you'd have to FOIL this all out first. Okay, so if I didn't want to FOIL it all out, I could just use my product rule. So this is two functions multiplied together. My first function is 3x minus 2, and my second function is x squared plus 2. So in order to find my derivative, I'm going to take the first function on its own, and I'm going to multiply that by the derivative of the second function, which using the power rule we know is 2x plus 0. Then to that I'm going to add the second function times the derivative of the first function. And with the power rule, the derivative of the first function is just 3. Now, if I wanted to FOIL this out, I could. Depends what your answer is looking like. Before this be completely simplified, let's go ahead and just FOIL it to get my final answer. So I would have 6x squared minus 4x plus 3x squared plus 6, which gives me a final answer of 9x squared minus 4x plus 6. Alright, so what the product rule can be really helpful with is, let's say instead of finding a derivative, I'm trying to find the derivative when x equals 1. I can get this question done a lot faster if I just use the product rule, because I won't have to FOIL this out, this whole 3 by 3 polynomial here. I can just find my derivative with the power rule, or product rule, and then just plug in 1 really easily. So let's go ahead and just find just f prime of x. So to find f prime of x, I'm going to take the original first function times the derivative of the second function. So the derivative of the second function is going to be 14x minus 2 plus 0. Then I take the original second function, and I'm going to multiply that by the original first function. Sorry, the derivative of the first function. So with using my power rule, that's going to be 2x minus 1. And now my final answer is asking me to find f prime of 1. So all I have to do now is just plug in 1 everywhere there's an x. And this is going to be a lot easier to work with than doing all that FOILing. So I'm going to have 1 minus 1 plus 3 times 14 times 1 minus 2 plus 7 minus 2 plus 4 times 2 minus 1. So again, I can finish up this math here. I've got 36 plus 9, which is going to be 45. Okay, so now we're going to do a couple more examples using what we just learned about the sine and cosine derivative. So now I have 4x times cosine of x. And normally I wouldn't be able to figure out this derivative unless I use the product rule. Because the problem here is I have two separate functions. 4x is a function, and then the cosine of x is a function. So the only way I can find this derivative is using the product rule. So I'm going to take the first original function times the derivative of the second function. And what we just learned is that the derivative of cosine is negative sine x. Then I'm going to add that to the original second function times the derivative of the first function. So my answer here, I can just rewrite this a little bit neater if I wanted to. That would be a negative 4x sine x plus 4 cosine x. And that's my derivative. Now be careful that you don't make these a little bit more difficult than you need to. Okay, so if I look at this next one, I have 4 times the cosine of x. Now, you only need to use the product rule when you have two functions multiplied together. Now, if I have something like 4, okay, if you remember, that's just a constant number. So we learned with a derivative that I can just take that 4 and move it to the front. So it's going to be the same thing as 4 times the derivative of cosine x. And I can find my derivative that way. So again, this will be a little bit simpler than going through the product rule. But if you did the product rule, you get the same answer because the derivative of 4 we know is 0. So again, finding my derivative this way, I would just get that f prime of x is 4 times the derivative of cosine, which is a negative sine x. All right, then the last thing we're going to look at, we have talked about a little bit, but this is just taking farther derivatives, not just taking my first derivative, but taking the second or third or fourth derivative, which is what all of these are. So f prime of x, that's the first derivative. Then when I have these two little lines here, that's double prime. Okay, so that's the second derivative. Then I have the third derivative and the fourth derivative, and these can keep on going. As you guys can see, I'm not just adding tally numbers, those are actually Roman numerals. So f of x is the sine of x. So what I'm going to do now is I'm going to find f prime of x. Well, the derivative of sine we know is cosine. Now the second derivative is the derivative of the answer we just got. So the derivative of cosine is negative sine. Now to find the third derivative, I'm going to find the derivative of negative sine x. So that's the same thing as a negative times the derivative of sine, which is cosine. And then finally, my last one, that fourth derivative, would be the same thing as a negative times the derivative of cosine, which we know is negative sine. So that's a negative sine x, which we know is actually a positive sine x. So that's my fourth derivative.